is recording now.
1, we have sine x will always be differentiated to give cos. 2, we have cos x. You miss Monday. I'm helping you now. Minus sine. 3, tan x. Sec square x. If you are around on Monday, you should be a revision too. So you got, if some of those that were around on Monday were saying, so how we put this in our head? So it used to be revising now. It used to be 4, cot x minus cosec square x. 5, sec x. What department? Are you paying transfer or cash? Cash. Sec x tan x. Wait, I'm recording my class. Wait. 6. Follow me. Cosec x minus cosec x cot x. 7. Arc sine x. Arc sine x means sine inverse of x. That is sine raised to power minus 1x. Sine inverse of x is arc sine. Arc sine x is 1 all over square root 1 minus x squared. 8. Arc cos x is minus 1 all over square root 1 minus x squared. 9. Arc tan x is 1 all over 1 plus x squared. Hello, those are the back. Okay, Alpha. Please, Micah, help us calm down the noise. 10. Arc cot x minus 1 all over 1 plus x squared. 11. Arc sec x 1 all over absolute value of x root x squared minus 1. 12. Arc cosec x minus 1 all over absolute value of x root x squared minus 13. Sine kx. Who is that? Please. I will differentiate you out of this class. I will differentiate. I will apply the rules of logarithm. Sine kx. We have k cos k. 14 cos kx minus k sine. 15 tan kx k sec squared. 16 in x 1 all over. There was a question in your test, they have in something. In this. In means natural logarithm. Does it log they gave you? No, they gave in. Maybe you're engineering. You learn from their question from their own Navi. You did a different question, Navi. Their own is in. There was one I saw in. 17. Ma. Someone saying sir. Ma. Cot. Yeah, there's cot here. Yes. E raised by x is e raised by 18. E raised to power kx is k e raised to power k. 19. Log x base a is 1 all over x in a. 1 all over x in a. Yes. Chelsea. Is your name Chelsea or is it a nickname? Is your real name? My dad is a Chelsea fan. It's good. Me now, I love Arsenal, so it means I have a child. I just say Arsenal. The first daughter is what? This first time I'm hearing someone bearing a club side name, Chelsea. I thought it's a nickname, it's a real name, Chelsea. Chelsea. Maybe your surname can now be Chelsea Man United. You understand? Name is Chelsea, surname is Man. So you say, what is your name? I'm Chelsea Man United. Or Chelsea Barcelona. Or Chelsea, one foreign name, surname will be Eyimba. Chelsea Eyimba. Class, follow me. Are you done writing this table? I must explain what's in this table. This was where we were looking at, and people were confused on Monday. Sir, are we going to cram all this in our head? What's going on here? Who applied me for this concept? Write down and I will explain. Don't worry. I will explain. I should leave the board. Come to this side. You are not seeing, I'm blocking you now. So I have to leave the board. I cannot leave the board. Come to this side. You can move, I cannot move. I have only one board. There are many seats. Eh? Class, please, because I have practice. I must sing tomorrow. I must do what? Sing everywhere. People will fall. People will do what? Have you not seen when they are singing, people will fall under the anointing? Have you not fallen under the anointing before? You say, be blessed. Oh, Pastor. Yeah, I've not fallen before. I don't know how it used to fall. How do you used to fall? Can someone teach me after the class? I need tutorials. You see? You put leg. Okay, finish writing us. By the way, that one is just a joke. Let's be serious now. Are we done? See, I'm charged up. I love mathematics. It's sweet. Are we ready? You're still writing? See how long it's taking you to write. How long will it take you to store it in your brain? But I'm sure you're done with this side. I want to play this side so that I can explain. Use this space to explain this side. Then clean this side and then explain this side. Now, so please write fast. Right. Class, anytime you differentiate sign, it must change to cos. No questions asked. No questions. Anytime you differentiate cos, you must change to minus sign. Tan changes to sec. Cot changes to minus cosec. Sec changes to sec x tan. Cosec changes to minus cosec s cot. Arc sine x, if they say differentiate sine inverse of x. Sine inverse of what? That's arc sine. It's 1 over 1 minus x squared, all square. Class. Sine x gives cos x. What if the sine 2? Class, differentiate sine 2x. First of all, focus on this 2x. Class, anytime they ask you differentiate sine 2x, focus on the 2. Differentiate 2x, you're going to have 2. Now, sine will change to what? Cos. Repeat your 2. Differentiate cos 2x. Differentiate this 2x, what do you have? 2. Cos changes to minus. Then repeat your 2. Differentiate tan 2x. Differentiate 2x, what do you have? 2. Tan changes to sec square. Repeat your 2. Because anytime you differentiate tan, it changes to sec square. Differentiate cos changes to minus sine. Differentiate sine changes to cos. Sine changes to cos. You can see cos changes to minus sine. Tan changes to sec. Class, differentiate 3 sine 2x. Class, there's a difference between just sine 2x and 3 sine 2x. For 3 sine 2x, class, first write this 3, nothing happens to this 3, write a 3. Then differentiate 2x, you have sign changes to repeat your 2. So anytime you have a number before the trigonometric function, nothing happens to that number. Don't say it's a constant to disappear. Nothing happens to that number. 3, nothing happens to the 3. Differentiate 2x, you have 2. Sign changes to what? Repeat your 2. 3 times 2, 6 cos. Now differentiate 5 cos 3x. Differentiate 5 cos what? Write down your 5, nothing happens to your 5. Now differentiate 3x, what do you have? 3. Cos changes to minus. Minus. Repeat your 3. Minus 5 times 3, minus 15. Sine 3x. Follow. Where is the minus from? When cos is differentiated, the minus will appear with sine. Differentiation of cos gives us minus sine. Differentiate 2 tan 4x plus 1. Differentiate 2 tan what? Nothing happens to these 2, write your 2. Now differentiate what is in front here. Differentiate 4x plus 1, you have 4. Because differentiate 4x, you have 4. 1 is a constant. This what does tan usually change to?
Sec squared.
Thank you, sec. Then repeat your 4x plus. Repeat your what? Now what is 2 times 4? 8 sec squared. Now differentiate arc sine. I didn't explain this on Monday, so focus. If you were last before that, I've done this one. I've got something I didn't explain. Arc sine x. We say we have 1 all over square root 1 minus x. Class. So if they say differentiate arc sine 3x, then differentiate what? Differentiation of arc sine 3x will be 3 all over square root of 3 minus 3x all squared, giving you 3 all over square root 3 minus 3 squared is 9, 9x. Thank God for everything.
So why did you want to change to 3?
Why did they want to change to 3? Because it was 1 because this is x. Class, differentiate this. Why did we change to 3? It's also a differential of x that is inside here. The square. Follow me again. Who understands already? Somehow you understand. You understand? Smart. What do you understand? Come. What do you understand?
This one, the coefficient of x is 1.
God bless you. This one that's appearing here is because x means 1. X means what? So this one you're saying, you don't just came here because you like still being here. It's because x is 1x. That's 1 all over 1 minus x. Now that it is 3x, will it still be 1? So if sine 1x is 1 all over square root 1 minus x, sine 3x will be what? 3 minus 3x, or after I wrote, because x square is x square now, 3 square is 9. So 3, this square first go 3 and x. 3 square is 9, x. Are you seeing it? Now, arc sine, so arc cos x is minus 1 all over square root 1 minus x. What will be arc cos 4x? Minus minus 4 over square root 4 minus 4x, or four square
16
x.
square.
Class, use the same approach and deal with everybody here like this. Now, did anybody say, sir? I have an answer? Can we find the square root? No, because of the minus between them. She's saying, can we find square root of 4, 2, and 16, 4? They are not just 4 and 16 standing on their own. There's the minus between. Class, this sine ks, cos ks, and tan ks, I've very directly explained it already, right? K is any number that comes before x. When I was saying sine 2x, it's 2 cos 2x. Cos 3x is minus 3 sine tan 3x. K means any number that comes before
X.
in x. Let's explain in x. In x, class, follow me. Any in means natural log. In means what? Follow me, follow me, follow me, follow me, follow me. Class, what is the differentiation of x? Is what? Class, anytime you ask to differentiate in of a function, differentiate the function and put it on top, then repeat the function under. Anytime you say in so and so, differentiate that so and so and put it on. Differentiate 3x plus 1, what do you have? 3. Now, what is this function? 3x. So the differentiation of in 3x plus 1 is 3 all over 3x plus. Class, in 5x squared plus 4, what will it be? 10x. Because 4 is the constant, disappears, right? All over 5x squared plus. Anytime you see in, it's just bonus they gave you. Differentiate the function, put it on. Then repeat the function undifferentiated under. Where did 10x come from? Okay. 5 times 2 multiply coefficient and if not for anything, since Monday that you have learned this thing, you didn't watch the video till now. This class was taught on Monday, basic differentiation. There's even one I posted for everybody, whether you are paid or not. I just see differentiation made easy by source. I just posted the Java general. Even one that is free, people don't even. Come on. You can't say you've not had data since Monday. That data used to enter TikTok. Go and watch one chapter of a particular course we posted. Study it. You missed the class. Like this class is being recorded now. And some of them I even generously post them on the general group. Few of them though. But I've stopped posting general group for everybody. It's always in my paid group I post it now. Let's now explain logarithm. I'll come to E, but let me explain logarithm quickly. Class, there's nothing in x and log x. Class, for logarithm there must be a base. Let the base be base A. Differentiate log x base Differentiate x, you have 1. Repeat the x under, just like in. Differentiate it and put it on top. Then repeat the question. But instead of that, you now put in. So differentiation of log x base a is 1 all over x in. Differentiate log x base a. Differentiate x, don't you have 1? You have. Now repeat the x under over x in. Let's take another question to see what I mean. Differentiate log 3x base 5. Differentiate 3x, what do you have? 3. Now repeat the 3x under all over n of the base n 5. So differentiation of log 3x base 5 is 3 all over 3x n 5. Better? Differentiate log 10x squared plus 2x minus 5 base 3. Log 10x squared plus 2x minus 5 base 3. Log 10x squared plus 2x minus 5 base 3. Log 10x squared plus 2x minus 5 base 3. What will it be? 20x plus 2 all over 10x squared plus 2x minus 5 and good, you've gotten it, and 3. Let us go to E. Differentiate e raised to power x is still e raised to power. But differentiate e raised to power kx. K means a number. Because differentiate kx is k, then repeat e raised to power kx. Class, it is just e raised to power x, the answer is still e raised to power x. This is one of the few variables that when you differentiate it, the answer is still the question. The answer is the differentiate e raised to power x, you have e raised to power x. So differentiate e raised to power 5x. Class, first of all, target this 5x. Differentiate 5x, what we have?
5.
Now repeat the whole question again. E raised to power 5. Differentiate e raised to power 3x plus 4. E raised to power what? First of all, differentiate 3x plus 4. What do you have? 3, because 4 is a constant 0, right? Then repeat e raised to power 3x plus. Straightforward?
Yeah.
So they say differentiate e raised to power anybody. First differentiate that power and put it down. Then repeat the whole question. Repeat the whole. Plus differentiate cot x. What do you have? Minus cosec square. Right? Differentiate cot. You have minus cosec square. So differentiate cot 3x. What will it be? Follow me. Differentiate 3x. What do you have? 3. So you have what? Cot change to minus. Minus 3 cosec square 3. Differentiate cot x is minus cosec square x. That means differentiate x, you have 1. Cot change to minus cosec square. Repeat your x. So differentiate cot x. Differentiate 3x, you have 3. Cot change to minus cosec square. Repeat your 3. Differentiate sec x. Is it not sec x tan x? Differentiate sec x, you have sec x tan. So differentiate sec 3x. Sec what?
3x.
Differentiate sec. First of all, differentiate 3x. What do you have? 3 sec 3x tan. Differentiate sec 3x. Differentiate 3x. What do you have? 3 sec 3x tan 3x. Now, I just told you that if you differentiate 2 sine 3x, what will you have again?
6 cos 3s.
Because nothing happens to these 2, right?
Yes.
Differentiate 3x, what do you have?
3
Sign changes to.
cos.
So if we have 2x sine 3x, what will you do? So nothing happens to these 2x, right? Okay, good. It means you are around on Monday. Use product. If you're not around on Monday, you might have thought we'll do the same thing here and here. Like these 2 questions are different. These 2 questions are what? How you differentiate this, how you differentiate this class? This guy has only one x component, but this one has 2x. X occurring here, x also occurring here. Class, you divide this into 2 components. This means 2x and this another 3x. There are 2 different components. Call the first component u, call the second component what? Class. So do not expect to use what you use to differentiate this to differentiate this. In this aspect, you're going to use product rule. Call the first person u, call the second person v. So that u equals to 2x and v equals to sine 3. U equals to 2x, v equals to sine 3. Class, differentiate u with respect to x, we are going to have du.
Yes.
And differentiate v with respect to x, you're going to have dv.
Yes.
Differentiate 2x, what do you have?
2.
Sine 3x, 3 cos. You know I got it right?
Yes.
Everybody understands it, good. What does product rule say? That dy dx equals u dv plus v du. Who is u? Who is dv dx? 3 plus who is v? Who is du dx? 2. 2x times 3 is 6x cos 3s plus sine 3s times 2. Don't use this 2 to multiply 3s. You know that, right? 2 has no right to multiply 3s. So 3s is in front of a trigonometric function. Instead, this 2 will just come to the back and become 2 sine. Final. Class, this is the differentiation of 2x sine 3x. Someone that was not taught well, we just use what we're doing here and say nothing happens to this 2x. Differentiate 3x, you have 3. Sine changes to cos. Repeat your 3x, you are wrong. 2x times 3, you now say 6x cos. You are. Notice that even this part of your answer is in our complete answer here. 6x cos 3x, but plus. Anytime you see x occurring 2 sides of an expression, just think of product rule immediately. So product rule is used to differentiate product of 2x components. Don't forget that Mondays we have Math 120. We have put Math 120 on Mondays. Don't be joking with that class. Most times this PSO is not free. Some of you come to PSO, you don't see or you think the class is not hold that day. Class, I've taught from Monday to Saturday. I've not missed one day. Any day you miss, just know that you miss class. I've taught. I told you guys when I started this class, I'm super consistent. Those who started with us early in the semester, I told you that from the beginning of the semester to the end, I will not miss one class. I said I cancel the class naturally. I just said there's no class today. Till your exam day, I will not miss one. Told you that I don't joke with my classes. If I fix a class, I have integrity. I have to come for my class. If you paid me for a class, I keep to my word. I teach my class to the end. Teach my class till the. So any day you come here, you don't see us, don't think that class is not holding. I rather look for a class anyway and teach that class than to cancel my class. I walk around, look for a class. That's how I do my class. So sometimes we use new lecture. Like Monday, I'm not sure PSL is free on Monday by 12. So normally you find us in new lecture. New lecture is behind us. So anytime you come here, don't waste in that did nothing today. Sometimes I might be in smaller PS classes. You'll see us there. These smaller PS classes or 3S. You call the first person U, call the second person V. So U is 2x, V is sine 3. So U is 2x, V is. Make sure the first person is U, second person is. U is 2x, V is sine 3x. Now differentiate U with respect to x, you have du is 2. Anytime you differentiate 2x, the x will go, 2 will remain, right? Anytime you're differentiating a number and x, clean the x, take the differentiate sine 3x. First of all, focus on this 3x. Differentiate 3x, you have 3. Sign changes to, then repeat the 3x in front again. Better? Now you have u, you have v, you have du dx, you have dv dx. The formula for product rule says that u dv plus v du, that means dy dx is equals to u dv dx plus v du dx. U is 2x, dv dx is 3 cos 3, plus v is sine 3, du dx is this one. What I did here is just to bring down these 2, right? Differentiate 3x, you have 3. Sign changes to repeat your 3. This one did not require product rule, right? Because there's no x in this side, but this one add x and x again. So call one person u, call the other person beta. Product rule done and dusted. Okay. Class. I want to remind you of the chain rule I've already taught you, because the question I want to solve now in that book, which one from Monday. Chain rule is used to differentiate function of functions, also called composite functions. Chain rule is used to differentiate function of composite function. Class, look at this kind of function. Given that y equals to 2x plus 1 raised to the power 5. This is a function of function. Y equals to 2x plus 1 raised to the power 5. Y equals to 2x plus 1 raised to the power 5 plus. This kind of function will go down not by product rule, but by chain. I taught the long method and the short method, remember? If it's the long method, replace everybody in this equation, inside this bracket with u. So let u be equal to 2x plus. So that means that y is now equal to what? U raised to the power. And you have two equations, equation 1 and equation. So as I said, y equals to 2x plus 1 raised to the power 5. Find dy, yes, find dy. We're looking for dy dx. First of all, simplify the function in the bracket with a simple maybe letter u. So instead of y equals to 2x plus 1 raised to the power 5, let y be equals to u raised to the power. So u equals to 2x plus. If u is 2x plus 1, means that y can be written as u raised to the power. Differentiate u to x, you have du. And differentiate y to u, you have dy du. Y to u is dy du. U to x is du. So differentiate 2x plus 1, what do you have? So because 1 is a constant, it disappears, right? You're right, I hope you're listening. You don't ask me to come again, you're not looking up. Differentiate u raised to the power 5. U raised to the power means 1 u raised to the power 5, right? There's an invisible one there, you can put 1 u raised to the power 5 and u raised to the power. Multiply question about 1 times 5. Bring down your u, subtract 1 from the power. We don't forget that u is 2x plus. So 5 u raised to the power 4. Replace u with 2x plus 1. 5 into bracket 2x raised to the power. This is a long method. In the exam, don't use long method, use shortcuts, please. I'll show you the shortcuts. Class, this is dy du. This is dy du, this is du dx. But what they ask us to find dy. To get dy dx, multiply dy du by du dx. Dy du multiplied by du. Du cancels du, what's left? Dy. So multiply dy du by du dx, you have dy. Who is dy du? 5 into bracket 2x plus 1 raised to the power. Multiply, who is du dx? Times 2. 5 times 2 will give you 10 into bracket 2x plus 1 raised to the power. This is dy dx. Class, dy dx simply gotten by multiplying dy du by du. Dy dx is simply gotten by multiplying dy du by du. When you multiply dy du by du dx, du on top will cancel du below, leaving you with dy. This is a long method, don't forget. For the shortcuts, there are only 4 steps and you are done. For the shortcuts, there are only 4 steps and you are. Step 1, bring down the power 5. Step 1, bring down the power what? Step 2, differentiate what you have inside the bracket. Differentiate 2x plus 1, what do you have? Step 3, repeat the bracket, 2x plus. Step 4, subtract 1 from the power, 5 minus 1. 5 times 2, 10 into bracket, 2x plus 1 raised to power. Final. This is a shortcut. Imagine someone suffering to do all these things in the exam, long method. Someone that knows the shortcut has left that question since you are still solving. Class, moving forward. Let me allow you to write a bit. Coming again with the shortcut. The shortcut says step 1, bring down the power. If you need to write it down, bring down the power 5. Step 2, differentiate what you have inside the bracket. Differentiate 2x plus 1, you have 2. Step 3, repeat the bracket like that, 2x plus. Step 4, subtract 1 from the power, 5 minus 1, 4. 5 minus 1. I just remember something. Coming again. Class, they say differentiate log x base. How long has it been off? Who knows? I've just been talking. As I be in class, so try always to be in physical class. Be around. Y equals to log x base a. What you know is that differentiate x you have, repeat the x in what? Another way of writing in a is log a base. In a is written as log a base. So if I want to remove this in a, I can replace it with what? 1 over x log a base. Now imagine facing this in the exam for the first time. This will first take you 5 minutes to be answering what's in. What's in now? That's why if you don't do past question, someone that has done it will be faster than you in the exam. I'm telling you. But there's some language you will not see in any test. It's the only person that will repeat it. Okay, this is what this always means. If I see this, this is what it means. If I see this, this is what it is. Something you have covered, you think you have not covered it because you have not done past question. This was not actually what I was looking for. If y equals to log 7x base a, find the y. Yes, a minus 7 all over 7x, b 7 over 7x log a base e, c 7 over 7x log e base a, d none. So anytime they don't have idea of answer, none of the, if there's no none, some of the, neither of the above, anything above, they don't rush it sharp. Is what? The answer is what? B. The answer is B. The answer is what? B. Interesting. Class. Class, if I say 7x, you have 7. Repeat your 7x. Normally you say in. But what's in A? Same thing as what? Log A base. Another thing you will learn. Follow me. Class, if they say differentiate y equals to x squared, what's wrong with these markers? What is your answer? Is it not 2x? The y dx is what? It's 2x, right? Yes. Differentiate y equals to x squared, your answer is 2. Yes. Now differentiate y, let 2 come down, let x go up. Y equals to 2 raised by x. It thank God for every. Class, differentiate y equals to x squared. We are used to x being the base and 2 being the. What if 2 is the base and x is the power? Will you say multiply coefficient and power? Are we joking here? 2 times x, 2x. I bet me I don't myself. Oh. Repeat the base. Subtract 1 from the power, I beg. Not be do pass myself. I just want to get C. May I pass this course? Class, follow me. This is wrong. This is differentiate y equals to 2 raised by x. Class, there's a rule. There's a what? Follow me, follow me, follow me, follow me. First of all, differentiate this power x. What do you have?
1.
Now, in 2, the base. In what? Then repeat your 2 raised by. 1 times in 2 is what? In 2. So our final answer is in 2 raised power x. I should come again. Anytime you have your base is a number instead of x, we are used to x being the base, right? The person down here, x is base, 2 is power. That's what we're used to, right? But when 2 comes down and x now goes. Class, differentiate this x. What do you have? N of this base 2. Then repeat your question. 2 raised power. What's there? I will get there, of course. Do you think this is the example I'll take? Some of you plan why you don't understand your present is that you are already taking the future. Just understand the present. Understand you're already creating on problems that are not yet existed in your head. Instead of dealing with the problem do you think this is the only question I'll give you? This is even an example. Always notice that the first example I always give is usually very simple. I always give the simplest example to you to understand, but then you now see me bring on down. I don't think I've already seen something in your past question. You didn't notice when I was smiling. Things I was just happy. The smile of wickedness. For what they are planning. What they are. Well, look at this now. Given that y equals to 4 raised to power cos x. Imagine cos x being a power. It's an example. Look at it. Open your question. Go to page 70. Let me know as I'm forming the question. So. If you go to page 72. Page 72, question 31. If you have your past question, you see it. Math 120. Math 120. What year is this? 2020, 2021. Math 120, 2020 slash 2021 set. Class, anytime your base is a number, and your x is now in a power like this. Class, let me give you the option so that you will see what I'm talking about. Option A, sine x in 4 raised to power cos x. Option B, minus sine x in 4 raised to power cos. Option C, in cos. Option D, in tan.
B.
Good. Someone has seen it. That's good. I like that. That's good. Someone has seen. Class, what did you first do? First, differentiate your power. Cos
X.
What will you have? Differentiate cos x. What do you have?
Minus sine X.
You see why I went to give you that table of the trigonometric functions first? Because imagine I didn't give you that table. You'll be struggling anytime I didn't cos sine. So I have to give you that table. Differentiate cos x, you have minus sine. Now, in 4, then repeat 4 raised to power. Is that not what we did here? Differentiate x, you have 1 in 2, then repeat 2 raised to power. So if I say differentiate y equals to 3 raised to power, I'm trying to marinate the wickedness, but it's not happening. Differentiate y equals to 3 raised to power 8x. Differentiate y equals to 3 raised to power 8. What will you have?
8.
Differentiate 8x, you have what? 8 in
3.
3 raised to power. Making sense, class?
Yes.
There's no way you say you're not learning something new here. Just compare one class to lecture. You see the vast difference in what you are gaining. They didn't even teach you in lecture, but it's in the exam. So imagine those that are only going for lecture. Now, what's your hope? Okay, y equals to tan inverse of x. Have I taught you this? Question 34. Find the y. Class, y equals to tan inverse of, is not something as arc tan x. It's simply asking you to find arc tan. It's in that table we gave. It's in that table we gave. If you follow this class very well, you just enjoy your exam. And some of you don't know why, but you have no open past question. You don't see, you see that, thank God we have done this, we have done this. Find, differentiate y equals to tan inverse of x, option A. Class, when you hear the option, let me know. Sec inverse of x. Option B, 1 over 1 plus x squared. Option C, sine x. Option D, 1 over tan x. What's the answer? B, right? 1 all over 1 plus x squared. Take that table I gave you, see there's B. You just enjoying your exam. You just be doing what? Check the table. This one is not about, you don't understand. Tan inverse of x changes to this straight. It's in the table I gave. That's why I started slide by giving that table. Because those that didn't come, I say they are lost. No, they are the same. They are the same. Just check. It's just the cover I changed. I actually planned to change the cover this set, but I need to just start producing with that cover. This is the from next set. This is the cover that we'll be using now. Class, differentiate e raised to power in x. Class, differentiate e raised to power what? In x. It's still recording now.
Yes.
Differentiate e raised to power in x. Let me write the option for you. Class, the option will shock you. Option A, 2. Option B, 1. C, 1 over 3. D, 2 over 5. Thank God for everything. Why did you say 1? Class, anytime x is a power, just know that it's the same thing we did in all these people that we do there. Class, the first step is differentiate the power, right? Differentiate in x, you have 1 all over x, remember? N of this guy, NE, in what? Then repeat, e raised to power what? In x. Is that how we should do it? Differentiate 2 raised per x. Differentiate x, you have 1. In 2 raised per
X.
Class. Let me now show you. Is this in your option? What you do is this. In 1 over x, in e is written as log. Log what? Log. In e is the same thing. If you look at it, wait. In e, yes. In e is written as log e base e. And e raised to power in x, it is the same thing as e raised to power log e base e. And log e base e is what? So you have 1 all over x. Oh, sorry, e raised to power in x, right? Is e raised to power log x base e, log x base. Now follow me. Class, 1 over x times log e base e is 1. Now e raised to power log x base e. Class, in logarithm rule, a raised to power log, follow me, a raised to power log b base a raised to power log b base a is b. A raised to power log b base a is b. So e raised to power log x base e is x. So that x cancels x and you have 1 times 1. Final answer is B. How can you go and meet this for the first time in the exam? You will fail. That was to study your passion before you enter the exam. Are you seeing this kind of questions in your textbooks? No. Are you seeing it in lecture? No. But it's in exam. Class, if you're asking me, ask they're putting 200 level at the back. Take the person and go and show them. Is this what you wrote last year? They are still at the back now. Some of you have here 2 friends. Show them, is this not what your exam you wrote last year? So you can know that it was actually the exam question I got and I solved. You have friends in 200 level. Get a person, go to the latest year, ask your friend in 200 level, is this the exam you wrote last? At least they will not lie for you now. So someone is bringing this lesson, you can't see it anyhow. They don't give you your question after your exam. After your exam, they will collect all your question paper from you. Because of wicked things like they don't want you to see. You are not seeing this in lecture, you are not seeing this in your test, but they are beginning it in exam. That's why I pity those that go for lecture only. Why didn't you come for tutorial? I was inside, we're having lecture. Sir, we're having lecture. But they're not bringing these things in the lecture, and they're in exam. I don't know how else to convince you that you should go and study your past questions. Even if I was not studying past questions, I will still be serious like I used to say it. Let me come again. Let me come. 1 over x. Just look at the question. E raised to power in x. Following the rule, we say differentiate in x, you have 1 all over. Now, normally we say in this guy, right? In e, then repeat e raised to power in x. After differentiating, we got this, but this is not in our option. We have not practiced this before now. It will take a lot of time in the exam for the first time to get 1. That first shock you experience now is what you should have experienced in the exam. But you have experienced it now, so someone like you now, you're a bit exposed. When you see a question, you won't be shocked. When you see in, you won't shake like someone that just in for in how now. I know what they teach us now. It won't move you again, right? I've seen it before. It gives you confidence. Class, we've gotten here, right? Now in E is setting as log base E, right? Now log base E base E, class, anytime the number here and number here are the same, the answer is class, log A base A is
1.
log B base B is
1.
so because E and E is 1, so this guy has, we have dealt with this guy. How do we change in E to log E base E? Because E normally is log. In class, what is in A? Is it not log A base E? So in E is also log E base
E.
and log E base E is
1.
Now how did we change? Now E raised to power in x, it is the same thing as E raised to power log x base E, because in is log base E, right?
Yes.
Because anytime this guy here and this guy here are the same, the answer is just this person here, clean every other person. And I showed you here, class. A raised to power log B base A, when this guy and this guy are the same, the answer is just this person B. So E raised to power log x base E is x, is what? So we have 1 over x here, we have 1 here, and we have x here. X on top cancel x below. 1 times 1.
1.
B. Better?
Yeah.
At least you will not say that you came to Saturday class, you will not gain something. It's not possible. So for the time you sacrificed, you've definitely gained the time you sacrificed. Anytime someone comes, check Saturday class, don't joke with it, because for a student to come Monday to Friday, they have already spent transport, then Saturday. I actually like giving you something strong on Saturday, because I know that it's not easy. Not all students can do it, come on Saturday. So I know that it's not easy, right? It's a sacrifice. It's not like convenient. Some of you are coming from town, some have to beg their parents to allow them. So I like my Saturday classes to be quality, to give you something strong. Now, we've gained that one. Now, class, we've also learned that shortcuts. Now, and all the trigonometric tables, you've learned it now. Let me actually end that question once and for all. Class, remember I just taught you chain rule. When I say y equals to 3x, is it recorded? If I say y equals to 3x plus 1 raised to power 5, you can now use shortcut to do it, right?
Yes.
Bring down the power.
5.
If I say 3x plus 1, what do you have?
3.
Repeat.
3x plus 1.
Subtract 1 for the power.
4.
5 times 3.
15. 3x plus 1 raised to power 5.
But what if you have y equals to 5, 3x plus 1 raised to power 5? If there was a number before the bracket. Let me not put 5, so it doesn't look like 5, 5. Let's put 7. Nothing happens, Abby. Nothing changes. Just bring down your 7 and continue the process. Bring down your differentiate the bracket.